I am coming in this fashion today. So today is live chemistry. Today is chemistry examination. So I do think it is necessary for me to come here and give you some tips on how you can perform excellently well in chemistry. So in separating technique, we have different methods of separation. Okay, we have different methods of separation. So please don't forget, this is very important. Most students are just reading and they're asking themselves, what area is Neco going to set? Yes, I know that's a very wonderful question that you may want to be asking. But the reason I'm here it's not just, I'm not coming here to reveal any question to you. In AZ Science team, we don't do malpractice, okay? Yes, what we do is to give you a key areas where you should expect based on the curriculum, based on the syllabus of the examination. Is that okay? So I don't want you to think that we are here to give you anything related to malpractice. Please, we are not that type of channel, all right? So in this area, so in separating techniques, you have to focus on the various method of separating substances, okay? For instance, we have filtration. Filtration is a separating technique. Filtration. Now, what is filtration? Filtration is a method of separating an filtration is made of separating an insoluble solid from a solution. What is insoluble solid? An insoluble solid is a solid that does not dissolve in the solution. So filtration is very good in separating that type of mixture. Okay, don't forget element, compound, mixtures, and the rest. Okay, so these are very important because they have to be separated. Now, you may, if you want to use filtration, you can use you can use funnel, okay, the filtration funnel, then put a filter paper on it, okay, then the one that drips down is called the filtrate. So when you have a funnel this way, right, you have a funnel like this, then you can have yes, you can have the substance inside, right, inside. So you just put it inside, all right. Then the separating mechanism will be here. That's the paper. The filter paper will be here. So whatever drips down here is called the filtrate, right? This is called the filtrate. The filtrate. All right. This is the filtrate. While whatever is left here is called the residue. This is called the residue. Please don't forget. So this is called the filtrate and the residue. So in case you find something like this in your exam today, all right, don't worry, use this method and you get it. Okay, then the next one is evaporation. Now evaporation is used for separating a soluble solid from a solution. Okay, this is for insoluble solids. For insoluble solids, okay, insoluble solids, insoluble solids. While this other one, evaporation, is for soluble solids. Evaporation. So evaporation is what? Separating a soluble solid. Okay, you must understand the difference. This one would dissolve in the solution. So, like for instance, if you have a sodium chloride, the common salt, the salt we use for cooking, if you add it to water, it will dissolve in the water. So, for you to be able to recover the salt, you have to evaporate the water. Evaporate the water, the mist, just evaporate the water, then you'll be left with the salt. All right. So, and that can be recovered. Then you cannot use filtration for sodium chloride in water because sodium is not insoluble, it is soluble. So that's why I use evaporation, right? Then the third one, which is very important, is distillation. We have distillation, right? So distillation is another method. I'm sure we are used to distillation. Now, distillation is used for separating two liquids, okay, with nearly equal, with different boiling points, okay? Yes, with different boiling points. So when you have, for instance, you can distill alcohol from water. You can see that, right? Yes, you distill alcohol from water. What you simply have to do is to heat the system, heat the mixture, then one will evaporate and then condense, all right? Yes, while the other one can be collected as well. So that is distillation. It's used for separating mixtures, okay? Mixtures of liquids with different boiling points. Please don't forget. Then we have what we call chromatography. We have what we call chromatography. Don't know, I'm sure we are used to chromatography. Chromatography. This one has to do with inks, okay? Inks. Then pigments, color pigments. What do you call color pigments? Please. Color pigments. All right, color patches. Now there are different methods of chromatography. Okay, we have the column chromatography, then we have the paper chromatography. Now the paper chromatography is the most popular one. We have so many other types of chromatography. The paper chromatography is very common. Don't forget that, okay? Because that is the one we use always in different parts, okay? We hardly use the other type. So in paper chromatography, you may be given a diagram, for instance, and you'll be told to identify the various pigments, right? For instance, a paper may be placed in an ink, and you'll be told to identify the various inks, okay, that comes out. So, for instance, you may be given anything, like maybe a drawing. So, a drawing, okay, it can come in different forms, but I don't know. But whichever method it comes, don't worry, you will always be able to get your own. Now, something like this, okay? Let's say you are giving something like this, and there is colors inside. There's colors inside, and you may be giving some points here and labeled. All right. So the points will be labeled, and you'll be told how many pigments and whatever is here, so that you can see how they can be separated. Okay. Questions like this can be solved, can be taken care of. This paper chromatography. This is the paper, the absorbent medium. Right. So different ways in which this can be done. Please don't forget that this is very important. And many other types of separation. We have the magnetic separation. Okay, magnetic separation is used for separating magnetic materials from non-magnetic materials. Okay, then we also have decantation. Please don't forget. Okay, we have decantation. These ones are not always coming out. I don't know why. Decantation. Please take note of this one. I'm showing you this one. Take note of all these ones. Okay. Yes, especially chromatography is very important too. Then take note of fractional distillation. Then there's also called crystallization and fractional crystallization. All these ones are very important, okay? Unlike decantation, people don't bother so much about them, all right? So decantation is simply used for separating liquids, okay, from other particles, you know. For instance, if you have your alum, you can put it inside water and all the materials will settle. Then you can simply decant or turn the top of the liquid. All right, so that's decantation. But take note of these ones, very important. Okay, take note of filtration, evaporation, distillation and fractional distillation, then chromatography. Okay, please take note of these four. It's very important. You are likely to find something like that. Okay, so don't get it confused. It's very simple. Okay, so if you have any question, let me know in the comment in the chat area. Let me just know. Okay, in case you have any issue, you have any question, you want to ask me a question, I want to be sure, okay, that you know that you are following this. Okay, now we proceed to the next one. Let's look at acid, base, and salt. The areas that might be asked acid, base, and salt. Yes, some people may ask questions like the acid, bases, okay, acids, bases, and salts, and salts. Now, know how to define them, know how to identify acid, base, and salt, and there are various types. Okay, there are different types and different examples. Okay, now what's an acid? An acid is a substance that will give out or donate protons or hydrogen ion, okay, in solution. That's what an acid is. Or an acid can also be defined as a substance that will react, okay, with a base to produce only salt and water. That's what an acid is. So there are different ways to define it. We have different types of acid, okay? Don't forget. Then we have basicity of an acid, depending on the number of hydrogen ions in the acid that is ionizable. Okay, ionizable hydrogen ions. Please don't forget, these are very important points that you need to take note of, so that when you get to the example, you will not be struggling, right? So please, that's an acid. What are examples of acid? We have hydrogen chloride acid or hydrochloric acid. Yes, please. Better call it hydrochloric what? Acid. So that is hydrogen and chlorine forming hydrochloric acid. Now, what do you have to know about all this acid? Let me just list the acid first. We have triazonitrate 5 acids. Okay. Then we have the H2SO4. Yes. Do you know the name of this acid? Let's put it in chat box. Let me be sure that you know the names. All right. This is tetraozo sulfate 6 acid. This is hydrochloric acid. This is triazonitrate 5 acid. This is a very strong oxidizing agent. Don't forget that, aside being a corrosive acid. All right. Then this is tetraozo sulfate 6 acid. Now, we also have another acid here, which is H2CO3. Okay, H2CO3. This one is triazocarbonate. Okay, triazocarbonate 4 acid. That's what this is. Then we have H3PO4. Yes, you see this? So all these are acids. Okay, the basicity of these acids are also very important. What is basicity? Basicity of an acid. Okay, it is the number of hydrogen ion in a solution, or the number of hydrogen ions in an acid. Okay, what is the basicity of hydrochloric acid? Hydrogen ion that can be given out is 1. Okay, that is 1. So the basicity is 1. Now, what is the basicity of triazonitrate 5 acid? It's still 1. Okay, so you write 1. Now, what is the basicity of tetraozo sulfate 4 acid? Tetraozo sulfate. This is tetraozo sulfate 6 acid. Sorry, tetraozo sulfate 6 acid. Okay, so this is triazocarbonate 4. This is tetraozo sulfate 6 acid. Okay, so what is the basicity of this acid? Is this one is 2. Okay, it can give out all the 2 hydrogen ions. This one is also 2. Don't forget. It can also give out all the 2. Why this is 3? Please don't forget. So these are the basicity of each of these acids, right? An acid may be dilute acid or anhydrous, or what you call corrosive acid. And some acids are very corrosive. Like these mineral acids are very corrosive, especially H2SO4, okay, tetrasulfate 6 acid, triazonitrate 5 acid. This is a very strong acid, please. Okay, they may ask you a question like, why is an all glass apparatus used in the production of this acid? Why is an all glass apparatus? Why is that all the apparatus used in producing triazonitrate 5 acid? Why is it that it is an all glass? Right? So an all glass apparatus means every point where this acid must touch must be glass. The reason is because the acid is very corrosive. So when you use any other materials, okay, any vessel made of any other materials apart from glass to produce this acid, the acid will do what? Since it is very corrosive, the acid will destroy it. Okay, yes, it will cause serious damage to the material of that vessel. That is why an all glass apparatus is used in the production of the production of triosonitrate 5 as. Please don't forget that this is very important. Now let's proceed to base and salt. Now what is base? What is base? All right, so the things you try to understand the properties, physical properties of acid, chemical properties of acids. Okay, these are very important. Please just make your last minute revision before 10 o'clock this morning or 9 o'clock, depending on when the exam is going to begin. And then the uses. What are the uses of acid? We know that acid are used in producing different reagents, okay, different chemicals. Then bases. What is a base? What is a base? And what's a base? And what's different between a base and an alkaline? You know, you need to understand this. Is very important. An alkaline. So what's a base and what's an alkaline? Okay, a base is a substance that will react with an acid to produce salt and water only. So acid plus base will give us salt and water only. Salt plus water, not just salt and plus water, but salt and water only. It will not give us any other thing. So if you get a reaction that gives you something else, it means that that is not neutralization reaction anymore. So this is a neutralization reaction. Okay, what is a neutralization reaction? You may be told these questions too. Neutralization. Yes, what is neutralization reaction? So what is neutralization reaction? Now, a neutralization reaction is a reaction between an acid and a base to produce salt and water only. Okay, or it's a reaction in which the hydrogen ion combines the hydrogen ion in a base or in an acid, sorry, combines with the hydroxide ion in a base to form water. Okay, so it can be said in different forms. Please don't forget that. Then what is an alkaline? What is an alkaline? An alkaline is a soluble base, a base that can dissolve in water, okay? That can dissolve, that is soluble. It's called an alkaline. Please take note of that. This is very important, please. Then don't forget the uses of base alkaline, okay? The uses. Then the properties. Don't forget that alkaline, they are slippery to touch, right? They are slippery. Then they have bitter taste. Acids have sour taste, but alkaline has bitter taste. All right. So they are used. These ones uses they are used for soap making and other things. Don't forget. Then their production method of production. Note the way acid and base are produced. Then what is a salt? Then we can go to salt. What is a salt? A salt is formed when an acid reacts with a base. When acid reacts with base, you can see that there was a salt here when acid reacts with a base. So that is a salt. Or a salt is simply formed when the hydrogen ion of an acid is replaced, okay, by a metal. That is how a salt can be formed. Now, we are going to look at the different types of salt. We have different types of salt, okay? We have the acid salt, and we have what's called acid salt. Yes, let's just look at salts. Then we have what we call acid salts. Yes, acid salt. Then we have what we call basic salt. Basic salt. Basic salt. Okay, basic salt. We have complex salts too. All right, so there are different types of salt. An acid salt have hydrogen ion inside. Okay, yes, still in the salt. Like sodium hydrogen carbonate. Sodium hydrogen carbonate is an acid salt. Look at this. This is an acid salt. Okay, let me come this way. Sodium hydrogen carbonate, something like this. Okay, sodium hydrogen carbonate. This is an acid salt, but there is a hydrogen ion there, okay, which is what dictates acidity. So this is an acid salt. If this acid salt dissolves in water, the solution will be either alkaline or acidic. But what we have here is that this, look at this sodium. So the solution here will be more of alkaline. All right. Don't forget, salt can be formed from a strong acid and a weak base, from a weak acid and a weak base, or from a weak acid and a strong base. So depending on which one. Okay, so please take note of all these things I'm showing you, because it is last minute what revision. Then what is pH? Please, this is very important. Take note of this. Okay, and this is very popular in Neco questions, always coming out every year. Okay, very, very common in Neco exam. It can come in form of theory or practical, in form of objective or theory. So please do well. What is pH? pH is called the acidity. It is the degree of acidity of a substance. Okay, that's the pH of a substance. Is the degree of acidity of the substance. It is written as the negative logarithms to base 10. Negative logarithms to base 10 of the hydrogen ion concentration. Okay, of the hydrogen ion concentration of a substance. Please take note. It is in negative logarithms to base 10 of the hydrogen ion concentration of a solution. That is the pH of the solution. Well, then we also have what we call pOH, please. pOH. pOH is also the same, but this time it is in negative logarithms to base 10. Okay, to base 10 of the hydroxyl ion of a solution. So this is, you may be given the hydrogen ion concentration in moles, okay, in molarities, in moles. Then you'll be told to find the pH, or sometimes you may be given the pH or pOH and told to find the pH. Sometimes you are given pOH and told to find pH. Yes, you can actually do that. Okay, so all of these are what you are going to focus on. Don't forget. Then you are giving substances. Let's say you are giving different substances. Let's say A, B, C, D. Let's say A, you are giving substance A, B, let's say C, let's say D, and E. Okay. Now look at these substances. Each of them, this one has pH. Let's say you are giving a substance like this. These are the substances. Let's say substances or solutions. Substances. Then here we are giving the pH. Let's say this one is 2, this is 6, this is 8, this is 10, and this is 14. You can see it. You may be giving something like this. Yeah, please take note of this. Something like this can come out in this form, in different forms. So your substance and the pH. Then A is 2. You tell me which of the following substance is the most acidic. Then which one is the most basic. Okay, sometimes they will put something like this. They will put something like this. They say which of them is neutral. Which one is neutral? Okay, so take note of things like this. If you have your pen and paper, just put this down, put all these things down. Okay, it can come in different forms. All right, please take notes. We are not showing you anything. We are just doing revision, just to ensure that you have your path, your direction. Okay, so please note all of this. Then we look at these are some of them. Please don't forget. Then we look at water. Okay, let's look at water. Very important. I'm sure you have written this one. Then we'll go to water. Now water. Some people will ask, why is water a very important topic? Why is Neco taking water very seriously? Or chemistry? We just drink water. Some of us don't understand what water is. What is water? Of course, water is a liquid. It is the most popular liquid. Okay, it is the most universally available liquid. So that's why sometimes we misuse it, because it is very popular. However, Neco or any other field takes water very seriously. Okay, now what is water? Now what are the things you need to know under water? First, no water cycle. Okay, no water cycle. Very important. Please see this. If you don't know it, go and learn it before. Just practice or tell your friend to help you explain it. Okay, water cycle. Okay, don't forget that there will be rain. Then when rain falls, erosion, okay, the rain goes into the ocean, then evaporation occurs and the rain goes back again. The water from the ocean evaporates into the atmosphere. That's a cycle. Okay, that's a cycle too. Then even from the land, during hot sunny weather, the water or moisture from the land evaporates. So that's water cycle. Okay, it's a cycle. It goes on and on. So that is for water cycle. Then we look at what we call solution, or before then, purification of water, or what you call hardness of water and purification of water. Okay, there are different ways to purify water. Yes, water purification. Don't forget, there are different ways you can purify water, especially when it involves separating techniques. You know, we have learned some of those ways. So then we look at hardness of water. What do you call hardness of water? Hardness. Let me just list them. Hardness, okay, of water. Hardness of water. Now we have two types of hardness of water, right? We have the temporary hardness and the permanent hardness. You don't even need, you just have to understand the way they work. Okay, what are the causes of hardness in water? Then what is a hard water? You know, these are very important, please. A hard water is water that does not form ladder. It does not foam. It doesn't form ladder easily with soap. And what is the reason for this? I will show you in this lesson. Please, let's proceed. Hardness of water. Now we have, this is due to some ions, okay, calcium and magnesium ions, okay, in form of hydrogen, hydrogen carbonates, all right, or sulfates. That is how these ions occurs. It is due to the presence of calcium and what? Magnesium ions in solutions, okay, in water. If these two are present in water in the form of HCO3 in this form, or in the form of in the form of yes, sulfate ion, SO4, right? If you have calcium, look at the calcium hydrogen carbonate, and you have calcium hydrogen carbonate. I think it's something like this, calcium hydrogen carbonate. Or you have magnesium hydrogen carbonates, magnesium hydrogen carbonates, right? Something like this. If you have this one inside the water, I can assure you that water you will be struggling to wash your clothes, okay, or struggling to wash your clothes, or struggling to foam or lather the water, and it won't work. Even with soap, even with good quality soap, so you keep wasting your soap because these ions are there. All right, so you have to heat. If it's temporary hardness, then ordinary boiling will remove it. But if it's permanent hardness, okay, very hard, permanent hardness, boiling cannot remove that kind of hardness. So you have to use some chemicals, okay, like soft soda, okay, can be used, and other methods that can be used for removing the hardness. Then let's look at the types of hardness. What you call types of hardness. Yes, I'm using this method so that you understand better. Types of hardness. When you get to example, just understand all these topics, and you will not be struggling. Now, types of hardness. What are the types of hardness? We have two types of hardness, okay? We have the temporary hardness. Temporary hardness. We have the temporary hardness. This type of hardness can be removed by what? By boiling. Okay, we can remove this type of hardness by what? By simply boiling it, boiling the water. Once you boil the water, then the hardness is gone. Okay, now it is due to the presence of calcium or magnesium ions in the form of hydrogen carbonate. In this form, okay, that's once you boil, it can be removed by boiling. Okay, when you boil this, what happens is that the calcium will be what? will be splitted. The calcium hydrogen carbonate will be splitted, and the calcium carbonate will be precipitated after boiling. Okay, this one will now come out when you boil. Okay, then after boiling, what you are going to see is that this substance, remember, this is a substance that is immiscible with water. Okay, yes, it will precipitate out after boiling. This is what you see are the walls of our pots and kettle after boiling. If you boil a hard water, you see this like four. It will cover the walls, the inner walls of your kettle. Okay, this is because it is this substance has been precipitated and is now used to cover the walls. Please don't forget, this is very important. Please, I beg you, make sure you do well in your exams. I want you to score A1. That's the purpose of this lesson. Now we go to what you call the next type of remember I said this one can be removed by boiling. It can also be removed by using sodium hydroxide. Yes, can be removed by chemicals, but this one can be removed by boiling. Please take note, and let's move to the next one. The next type of hardness is called the permanent hardness. Yes, this is stronger. Okay, permanent hardness. Nothing is permanent because it is stronger. It has a stronger effect. That's why we call it permanent hardness. Please take note. Not that it's actually permanent. So these ones cannot be removed by boiling. Okay, this one can be removed by what? By boiling. So if you boil, it will go, and the hardness will go. If you boil, remove this one by boiling, but this one cannot be removed by boiling. All right. So please take note. This one occurs in the form of tetraoxobases. Yes, it's still calcium and magnesium ions, but in the form of tetraoxobases. Please. So, and there's need for this to be precipitated, but since it cannot precipitate, what will happen is that you simply have to bring in some chemicals to it, such as soft soda. Oh, yes, you can use soft soda or any other substance. There are other substances that can be used, okay, and it will be precipitated out, and that solves the problem for this hardness. So that is for this type of hardness. Please take note of hardness of water. Then when you are done with hardness of water, go to solution. Then from solution, solubility. The question is, what is solution? What is solution? Please take note of the word solution. A solution consists of homogeneous mixture. Okay, homogeneous means uniform. Please take note of that word, homogeneous. It means uniform. So solution consists of homogeneous mixture of two or more substances. All right? Yes. So that's what solution is. Then we have types of solutions. So don't forget that. These are very important. Then the next one is solubility. 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 Sorry. That is soluble ability. Put together, soluble ability, solubility. What's solubility? Solubility is the ability of a substance, okay, the ability of a substance to be able to dissolve in a solvent to form a solution. That is solubility. But in chemistry, solubility is the number of moles of solute that dissolves in 1 dm cube of a solvent to form a solution. Okay, number of moles of a solute that dissolves in 1 dm cube or 1000 cm cube. It can be number of grams of a substance or of a solute that dissolves in 1000 cm cube, okay, of a solvent, yes, to form a solution. So that's what solubility is. You may be given the solubility of a substance and told to calculate. Please do well to do that. Remember, solubility is affected by temperature. So when you see temperature in solubility, don't include the temperature. The temperature is just telling you the solubility or the ability of the substance to be soluble at that particular temperature. Once temperature changes, solubility changes. Please take note of these little things you need to know. So that is that for water and solubility. Solubility is applied. Okay, it's applied in pharmacies and in industries. Brewage industry or brewing industry. I'm sure you know Coca-Cola, Coke, and other forms of food industries. Yes, even in petroleum, solubility is also applied. right? So please take note of all of this. That is for water. Okay, once we are done with water, we proceed to another aspect. Let me show us another area that we should look at. Okay, I just carved out some of these areas so that we will not be struggling to find out those areas. Then organic chemistry, and some of us may not know this. Organic chemistry, yes, what's organic chemistry? Please take note of organic chemistry. It's very important. Yeah, organic. Organic. Most students will run away when they hear the word organic. Please don't run away. I did not come this morning to give you headache. I came to explain certain things to you so that you don't have issues. Okay. Now, organic chemistry. What's the word organic? What does it mean when you use the word organic? What's organic chemistry? Organic chemistry is chemistry that deals with carbon. Okay, yes, carbon chemistry that deals with carbon compounds, with exceptions to the inorganic compounds like carbonates, oxides and the rest. No, that's not what we are talking about. Okay, what we are interested in here is just for the organic parts. Okay, like dead and decayed matter. So all these are organic chemistry. Now, organic chemistry, don't forget petroleum under organic chemistry. Yes, I know why I'm bringing petroleum personally. Okay, petroleum is very important. Petroleum. The word petroleum. There are two things here. We have petroleum. Okay, petroleum. Do you get it now? Oleum is a thick, dark liquid. Pet is rock. Petrology. So petrology. Okay, so it means a thick, dark liquid. Okay, gotten from rock. Yes, petrology is the study of rocks. Mineralogy is the study of minerals. So this petrology, it is study of rock, petrology. So this petroleum, please take note of that. This is very important. Now, what's petroleum? What do you need to know about petroleum? One, don't forget the refining of petroleum, what you call fractional distillation of petroleum. There are two things you need to know about petroleum. You need to know what you call octane rating. Yes, you may be told under this, what is octane rating? Please take note of octane rating. What is octane rating? Octane rating has to do with the performance of petrol in an internal combustion engine. Okay, that is octane rating. That has to do with what? The performance of petrol in an internal combustion engine. Okay, please take note. It is the ratio of the branch chain to this. Is the ratio of the branch chain to the straight chain hydrocarbon in a given quantity of petrol. Please, that is octane rating. Take note of that, please. Then we have what we call cracking. Cracking and reforming of petrol. This is very important, very interesting. Cracking and reforming of petrol. Don't worry, I'll come back to octane rating, okay? But let's look at cracking. To crack means to break into smaller units. That's what you are doing. Then to reform means to change the form. Reform, change the form. These are the two, okay? Both of them are used to increase the quantity of petrol. Please, petrol, not petroleum, but petrol. Petrol. You notice that, I don't know if you are aware already, but I'm sure, yes, as a student of chemistry, you should know, you should have known that during the process of refining of petroleum, or what you call fractional distillation of petroleum, you will notice that the fraction of petrol is too small. It is small in relation to the demand. Remember, petrol is the most demanded of all the fractions of petroleum. Diesel, kerosene, heavy oil, gas, and so on. So among all these fractions of petroleum, petrol is the most demanded in the world, in the entire globe. So we need to increase the quantity of petrol such that it will be enough for the populace, for the entire world. The only way to do that are these two methods. Okay, this is the easiest way to do it. There are other methods. Okay, petrol can be produced from coal, or yeah, from coal you can get petroleum and petrol also. Okay, then cracking is the process of breaking down heavier hydrocarbons into smaller hydrocarbon molecules. That's what you call cracking. Okay, you can crack your petroleum or petrol or heavier hydrocarbons like diesel. No, you can crack diesel to produce petrol. You see that? So heavy oil, you can crack them to produce petroleum. Then you can also do what you call reforming. Reforming is actually done to increase the performance of the fuel. Okay, yes, of hydrocarbon. Yes, in an engine. So these are things you must put into consideration as you get ready for your exams. Please don't forget. Okay, examination is just about 3 or 4 hours from now. You'll be in the exam hall. So I wish you success. Okay. And now after this, we look at what octane rating. I said I was going to come back to octane rating. Yes, what's octane rating? Octane rating, I said, is the performance. Okay, it is the performance of petrol. Yes, performance of petrol in an internal combustion engine. If you have octane rating is from 0 to 100. So 100 means the performance is so poor, as in extremely poor. Okay, this is where you have straight chain, while this one is where you have branch chain hydrocarbons. So you have to reform the straight chain to get branch chain. So it's a measure of the branch chain hydrocarbon in an engine. Okay, straight chain hydrocarbon burns very fast, and once they burn very fast, they can lead to knocking of the engine. They can lead to the damage of the blocks of the engine, but the branch chains do not. So hydrocarbons are rated between 0 and 100. Please take notes. The straight chain hydrocarbons perform poorly in an internal combustion engine, while the branch chain does not perform poorly. It performs very high. Okay, so that is how it is rated. Please take note of this, very important. So that is that for petroleum and refining of petroleum. Please take note of petroleum refinery. Then we move to the next one, which is alkane, and alkyne. Yes, and that is hydrocarbon. What do you call hydrocarbon? Okay, alkanes. What are alkanes? We are going to look at alkanes. Alkanes are a group of hydrocarbon. They belong to a particular family. Yes, this is family. This is a family of its own. Alkanes. Then we have alkenes and alkynes. Please take note. They are carboxylic group. It's called carboxylic group. They have general method of preparation. They have similar properties. Okay, they have some. They differ. Each member differ by CH2, right? Yes. Then they have the same functional group because they have one bond, single bond. That's what we call them. Examples of alkanes. We already know them, right? So just read them. But we have methane, methane, which is the major constituent of natural gas. Please take note. The major constituent of natural gas is methane. This is methane. Okay, methane is the major constituent of natural gas. Don't forget, we have methane. Then we have ethane. Ethane. Okay, when you add two here, that's ethane. The general formula for alkanes is CnH2n plus 2. You can see it. So when you add one here, what do you do? When you add one here, so this becomes 4, right? 2 times 1 is 2 plus, so that's 1, 4. When you add 2 here, come 2 times 2, which is 4, plus this 2, that is 6. So it's like adding 1 here and 1 here also. Yeah, adding, okay, not necessarily 1. Okay, just know that this is formula. So for n equals to 1, look at it here. You have 1 here, that's C1. Then 2 times 1 is 2 plus 2, that is 4. Please take note. We have methane, ethane. Then we have propane. Okay. Then after propane, we have butane. Right. Then butane, we have heptane. We have hexane. Yeah, we have heptane, then hexane. We have hexane, then we have octane, nonane, decane. So we have all of them under this. Note this, all of this, please. I'm sure you are very used to them. Note their properties. Note the one that's very important in each of the families, please. So first, note their general method of preparation. So how are alkanes produced? An example of an alkane is methane. How is methane produced? Yes, I once asked one of my students how methane is produced. All right. So methane is produced by the reaction between brine, okay, by the reaction between soda lime. Yes, by the reaction between soda lime and ethanoic acid. Yes, soda lime and ethanoic acid. Okay, look at this ethanoic acid, CH3, then COOH. This ethanoic, yeah, sodium ethanoate. Okay, let's check whether sodium ethanoate plus soda lime. Okay, we do remember we are actually, this appears like soda, right? There is soda lime. This is sodium ethanoate. Yes, we are going to use sodium. I think sodium ethanoate here with soda lime. Then this becomes sodium carbonate. Then CH4. Yes. Now, if you combine these two, you are going to have CH4, then plus Na2, CO3, right? Let's check it out. C is 1 here, is balanced. Then H is 4, and C, look at this, C is here. Look at this. Another C is here, right? Then 1, 2, 3. Look at it. So with this, you have been able to produce methane. Same applies to ethane, okay, ethane, propane, and others. Yes, this is soda lime. We normally don't use the normal soda. Okay? The reason is because it is very corrosive and delicate also, and it will have a way of affecting reaction negatively. So that's why we prefer to use the soda lime, what you call soda lime. Please take note of that. That is very important. Then method of preparation, then general properties of alkanes, and so on. Then we'll proceed to alkanes. Remember, these ones have single bonds, so they are saturated. But for the alkanes are not saturated, okay? They are unsaturated. Alkanes are unsaturated. They have double bonds, so they can decolorize bromine water. Yes, because they are unsaturated, right? So alkanes, the general formula for alkanes is CnH2n. This is alkane, right? So the smallest is C. Okay, if you put 2 here, you have ethene, right? Ethene is C2H4. C2H4. Then the next one is C3H3 times 2. 3 times 2 is 6. So just times 2. Okay, times 2 of the quantity of carbon atoms that will make hydrogen atom. So that's what it is. We have ethene, ethene, propene, butene, and so on. Okay, till we get to octane. So these are all the processes. Please take note. I hope you are with me. I just hope I'm not talking to myself alone. I hope we are learning something from here. Okay, how many of us are here? Let me be sure that I'm not talking to myself alone. All right. So we proceed to the next one. Okay, I am India. Oh, thank you very much. Yes, thank you very much. Student life, I appreciate you. God bless you. Oh, God bless your hustle. Thank you very much. I appreciate all of you. Thank you for taking out time to teach us. Oh, thank you so much. Chun-Li, thank you. I appreciate you. I hope you have subscribed. Please do it, subscribe. All right. I appreciate all of you. You are such wonderful people. And each time I read comments and chats, I feel very elated because you are just too much. Please, don't get me too elated so that I can continue. Thank you very much. I appreciate you. All right. So alkanes. Now the general formula for alkane is CnH2n. All right. So that is what the general formula is. Now, what do you have to know? It's good you know exactly what to do in an exam. The reason why some students find it difficult to pass an exam is because they are just randomly reading and concentrating. They are not able to point out what they actually need. Okay. First, know the general molecular formula. Okay, this general formula is very important. Then know what you call isomerism in organic chemistry. Isomerism is very important. Polymerization is very important. Okay, yes, I know we have condensation, and yes, it's a type of polymerization, but I will explain all of them. Okay, yes, where water is eliminated and so on. So this is for this. And remember, they are unsaturated. Yes, that's very important. Then what else? Method of preparation. How do you prepare this? Yes, somebody will ask me, how do you prepare alkanes? Remember, to prepare alkanes, we combine sodium ethanoate with soda lime. But this one, we are going to combine alcohol, C2H5OH. Okay, C2H5OH. Let me make it bigger. C2H5OH. Now, the issue here is that we want to dehydrate this. Okay, let's dehydrate. That's what we are doing. Okay, if you dehydrate this one, what will be left? We'll be left with remove OH, remove this one. Okay, to dehydrate it, remove this. That's what we call dehydration. Please take note. Dehydration. I don't know if you understand what I'm saying. To dehydrate means to remove water. Water is H2O minus H2O. That's the meaning. Remove H2O from here. Okay, it's mathematics. This is not chemistry, it's mathematics. How many H? Remove one H from here, remove one from here. Okay, that's H2. It's gone. Then remove this O. So we're now left with C2, H what? H4. Don't know if you understand what we did here. You see it now. I want you to understand what we are doing here. We have removed OH and one H from here. Okay, remove this one from alcohol. This is ethanol. Ethanol will give us 18. Ethanol will give us what? 18. Please. Ethanol will give us 18. Then the other ones will also give us the same thing. All right. This one gave us ethanol, gave us 18. Propanol will give us propene. Butanol will give us butene. You see that now? So that is how just dehydrate alcohol. You will get alkanes. Okay, alkanes are gotten by dehydrating alcohols. Please don't waste time. Okay, when you get to exam hall, don't waste time. Please do well to subscribe if you haven't. So please, I need a subscription. Very important. Now we go to the next one. We move into the next one. This is method of preparation. Same for every one of them. Don't forget. So that is for alkanes. They are unsaturated because they have carbon to carbon double bonds. This is alkanes. All right. So this one is methane. This is called methane. This is ethene rather. Ethene, as in C2H. Okay, no, sorry. This is not ethene. You can see that we still have a lot to do here. This is carbon. This is C2. Yes. This is. We need to add one more here. Add one more here. Yes, because it's C2H4. Please take note. It's C2H4. That's what it is. Please take notes. Note this because let me explain so that you can get it better. Okay. Make sure that the number of carbon atoms and the number of bonds attached to hydrogen or to carbon is up to 4. It must be 4. Okay, just look at what I want to do now. It's 4. It must be 4. This is 1, 2, 3, 4. Okay, 1, 2, 3, 4. So it must be 4. If it's not 4, then it means that we need to add others, okay, to make sure that we complete it. It must be 4. Please take notes. Now we proceed to the next one, which is alkynes. Yes, alkynes. What are alkynes? What are alkynes? Sorry, I need to write in small letter now. What are alkynes? Alkynes have triple bonds. They have carbon to carbon triple bonds. They are unsaturated, highly unsaturated hydrocarbon with carbon to carbon triple bonds. Please take note. Now, what are the general formula for alkynes? Alkynes have the general formula CN H2N minus 2. CN H2N minus 2. Yes, these are alkynes. Yes. So for the first one, which is ethyne, ethyne is the first alkyne. So ethyne. So what do we have? We have C2H2, right? C2H2. Yes, because this is 2 here, C2. Then this 2 times 2 is 4. Then minus 2 is 2. All right, that is exactly what it is. So this is ethyne. So know their method of preparations, know their general reactions, know every other thing that concerns them. Okay. Remember, they also decolorize bromine water because they are unsaturated. They have carbon to carbon triple bond. So from this, how many will be added? You can see that we just need. You see it now. We just need only 2 hydrogen atoms, right? Because we already have 1, 2, 3. So we need this one to make it 4, right? Yes, that's 4. Make sure that it's up to 4 that is surrounding carbon atoms. Now we look at one of the things that we're going to look at, method of preparation. Then don't forget that each successive member differs by the alkyl group CH2. Okay, I will explain this. Let me explain so that you will get it when you get there. Okay, I don't want us to waste our time. Now, give the general molecular formula for this one. I'm sure we know all of that. We can explain this. Know the general formula. What is the general molecular formula for alkynes? I'm sure we know it. I've given you already. Then this is H minus this and that, right? Then we look at yes, the general molecular formula is CN H2N. This is extremely important, okay? This is very important. Each of them have their general molecular formula, so use this one for it. Now that gives us, that's enough for this class. Then we'll proceed to the next one, which is isomerism. What is isomerism? This is very important, okay? Isomerism. Now, what is isomerism? Okay? Now, isomerism has to do with structural differences between among compounds with the same molecular formula, but their structural formula differs. Okay, so it is isomerism is simply takes place because a particular or different compounds may have the same molecular formula but different structural formula. Okay, that is isomerism. That's where isomerism occurs. Now, let me show you something here. For instance, butane. C4, butane is C4H10, right? That is for butane. Butane. This is for normal butane. Normal butane. Okay, C4H4, C4H10. Now, if you want to write this one, the way it is long now, this is how you're going to write it. Just look at what I'm going to write here. Okay, this will give us, remember, it must be four bonds. So which means we need 1 here, 1 here, 1 here. Yeah, we already have 1, 2 attached to this one. So we need 1 here, 1 here. Here we already have 1, 2 attached to this one. So we need 1 here, 1 here. Here we have only 1. So we need 3, which means 1 will be here, 1 will be here, 1 will be here. So continue. 1 here, 1 here. Then here we have 1, we have 1 here. This, yes, we have one here. Okay, here one, we have one, we have one. You can see it now, right? So if you calculate it, you will get 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see it now. So that's exactly the normal butane. This is called the normal butane. Normal butane. Normal butane. Normal butane. Please take note. This is called normal butane. All right. So, but there are other isomers of butane. Okay. Yes, we have the 2-methyl propane. 2-methyl propane. So we can have the 2-methyl propane. Then we have the 2,2-dimethyl. Okay. Yes. 2-methyl propane. Let's do the 2-methyl propane. Yes, we have the 2-methyl propane. That is C, and C. Here we have C. All right. So we have our H here. H here. We can make it. We can condense it. This special form, but we can make it condensed. We can condense it, but let's leave it in this format anyway. Look at it. So here, bring your H, another H here, then another H here. This is 2-methyl, 1, 2, 3. This is 2-methyl propane. All right. So that's what it means. It means 2-methyl propane. I hope this is well understood. So this is 2-methyl propane. So these are isomerism. This is called structural isomerism. We have another form of isomerism. We have the geometric isomerism. Okay, the geometric isomerism, like the cis and the trans, is called. They are called geometric isomerism. Please study the types of isomerism and see how you can work your way through as you proceed to score A1 in today's examination. So that is that. Then we look at polymerization. Polymers. How are polymers formed? The process is called polymerization. Polymers, how are they formed? Remember, we may not be able to revise everything, but the key areas, that's what we are looking at. Polymerization, right? Yes, I hope I got it right. Yes, yeah, let's polymerization. Okay, how are polymers formed? Please take note of that. Very important. Polymers are gigantic molecules, and they are usually formed when smaller, lighter, less massive molecules combine together. Okay, then they form gigantic molecules. Like rubber is a polymer, plastic are polymers. So even benzene is a polymer. I'm sure you are aware. So for instance, polythene is formed by ethene reacting together. Okay, when ethene reacts, we form polythene. So that is polymerization. Please, we have the different types of polymerization. Try to read them. You just need to understand how questions can be set from there. Okay, please take note of all of that. I think you will not have any issue once you understand how to go about it. All right. Now we look at the other areas. Okay, I think these are the basic areas. So if you have any issue, please don't forget to keep sending me message. My our WhatsApp number is there in the platform. I will keep replying you, and the process continues not only here. I just want to show you some of these areas that you have to focus on. Pay attention on these areas. Then don't forget the other areas that we didn't mention, but it's very important, like metals and their compounds. Okay? Yes, metals. Focus on those metals and how they are extracted. The reactive metals. The reactive metals are usually extracted by electrolysis, while the non-reactive ones are usually extracted by furnace method. Okay, yes, by reduction, what you call reduction. So these are some of the areas. So thank you very much for joining AZ Science TV today. I know I do hope you got value in this video today or in this live stream. Don't forget to subscribe if you haven't. Some of us have been watching all this while. I didn't see you watch. But thank you for those who liked and shared this live stream. I appreciate you a lot, and I do hope that you will do well in your examination, and nothing will stop you from having your heart desire. But do well to ensure that you keep asking questions to clarify certain areas, or all the areas that are not clear to you. So I'm going to be leaving right now to carry out my official engagement or official assignment for today. So thank you. I remain your one and only AZ brother. So I do hope you will keep watching AZ Science TV. Also check our videos for some of these solutions. Thank you very much. And for now, goodbye and success and excellence.